GCSE question of the week, week 13, foundation first. So we've got a pie chart question, and we've got two pie charts showing some information about medals won by Germany and medals won by the Russian Federation. Germany won 7 bronze medals, so obviously we're talking about this part of the pie chart here. We're on Germany and we're on bronze. So we know that that part of the pie chart is worth 7 bronze medals. And our question 1 is, how many gold medals did Germany win? Now there are different ways to do this, but perhaps the simplest is to think, well, that 84 degrees is worth 7 medals. So it'd be handy if we could find out what 1 medal was worth in terms of degrees. So how will we do that? Well, if 84 degrees is 7 medals, if we divide by 7, then we should find out how many degrees there are per medal. Because 7 bronze medals is 84 degrees. So what's 84 divided by 7? Okay, well, I could check on a calculator. We could do a division. I reckon that's going to be 12. Okay, if we weren't sure, we could do 84 divided by 7. That'd be 7 and 8. 1 to carry. We've got 12. Okay, so what does that mean? That means that 1 medal is worth 12 degrees. So on the diagram, 12 degrees is worth 1 medal. 12 degrees is 1 medal. So how many gold medals did Germany win? Well, the gold medal part is clearly this part of our pie chart. And this part of our pie chart is 120 degrees. So we know 1 medal is worth 12 degrees, and we've got 120 degrees. So I reckon that's worth 10 medals. So we could have said 120 degrees divided by 12 degrees. That's going to give us 10 medals. We could probably just see that straight away. So the answer to question 1, I think, is 10 gold medals. Right, Graham says, the pie chart shows that Germany won more gold medals than the Russian Federation. Is he right? And you must explain your answer. Well, if we look at the gold medal part of the Russian Federation pie chart, it's definitely true that that's only worth 72%. So we've got 72%, sorry, 72 degrees, not 72%. That's only worth 72 degrees. The gold part of our Germany pie chart is 120 degrees. So it's definitely true that the area of the pie chart on the Germany one is bigger for gold than it is for the Russian Federation. But does that mean that it shows that we've got more gold medals in Germany than in Russia? No. Why not? Because we don't know what the total number of medals is. There's no information that tells us how many medals the Russian Federation won. So we could work out what fraction of the medals that the Russian Federation won were gold, but unless we know the total number or the number of golds they got, we've got no idea how many gold medals that translates to. So what could we put? No, because we don't know the total number of medals. So no, because we don't know the total number of medals that the Russian Federation won. Okay, if we did, we could work out what fraction were gold, and we do that by 72 degrees divided by 360 degrees. That would be the fraction multiplied by the total number of medals. I should probably say there we don't know the total number of medals for the Russian Federation. So all we know is what percentage of their medals were gold medals. We don't know how many they actually won. Okay, high tier question. Here are the first 5 terms of a quadratic sequence. 1, 3, 7, 13, 21. Find an expression for the nth term. Right, so quadratic sequences are tough. Okay, we need to do a fair few steps to get these right. Okay, and really you need to learn what these steps are. So quadratic sequence. The first step is find the first differences. So difference between 1 and 3, we've got plus 2. Okay, 3 to 7, we've got to jump plus 4. 7 to 13, we've got plus 6. 13 to 21, we've got plus 8. Okay, so this is clearly not an arithmetic sequence. These jumps are not constant. So what do we do next? We find the second differences. Let's find the second differences. The second difference is, okay, the gap between the 2 and the 4, we've got 2. gap between the 4 and 6, 2, gap between the 6 and the 8, we've got 2. Okay, now that 2 tells us the number of n squareds. Okay, but doesn't just tell us it's 2n squared, we have to remember that we halve the second differences. So we found the second difference is 2, we have to halve that second difference. Okay, so half of 2 is clearly 1. That tells me we've got 1n squared in our nth term rule. Okay, so not 2n squared, but n squared. We halve the second difference, that gives me 1n squared, just n squared. So we know the first part of this nth term rule is n squared. So what do we do next? Well, we think, right, when n is 1, 2, 3, 4, right, what terms do we get in the sequence? Well, the sequence gives us 1, 3, 7, and 13. So these are the terms in the sequence. When n is 1, that's the first term, gives us 1. When n is 2, that's the second term, gives us 3. When n is 3, that's the third term, gives us 7. Okay, when n is 4, third term's 13. Okay, and we already know that the first bit of our nth term rule is n squared. So what would n squared give us? Well, when n is 1, n squared is 1 times 1, that's just 1. When n is 2, n squared is 2 times 2, that's 4. When n is 3, 3 squared is 9. When n is 4, we get 16. So what we have to do then is think, right, the actual sequence is this. And we know that the n squared bit that we've just worked out gives us this. So we need to work out the difference between those to see what's left over, if you like. So we're going to subtract those n squared terms from the actual terms in our sequence. In other words, we're going to do 1, subtract 1, which gives us 0. We're going to do 3, subtract 4, which gives us negative 1. We're going to do 7, subtract 9, which is negative 2. And we get 13, subtract 16, which is negative 3. Okay, so we see that we don't get a constant here, right? If we got a constant, we could just stick +2 or -3, whatever it might be, on the n squared, but we don't. So this is looking to me like it might be a quadratic sequence. So no, it doesn't. This is looking to me like it might be an arithmetic sequence itself. Okay, so let's treat it as if it was an arithmetic sequence. We'll work out the jumps, and the jumps, well, we're going down 1, we're going down 1, and we're going down 1. So now we've got a fixed difference, a fixed jump between these terms. It's -1. Okay, and what would the rules be in an arithmetic sequence? Well, that jump, that gap there, tells us how many n's. So this is going to tell me we've got -1n, or just -n. And remember, in the arithmetic sequence, our last job is to work out the 0th term. Okay, what goes before the sequence that they give us? So working backwards, like we're subtracting 1 every time, if we go backwards this way, we've got to add 1 each time. So I think we're going to get 1 here, +1. So my final sequence is n squared minus n plus 1. Okay, so I think that the sequence is n squared minus n plus 1. Right, now we better just check that works out. So if we're correct, then we should be able to check out, right? So when n is 1, okay, let's substitute 1 into this nth term rule. N squared is going to give us 1 squared, which is 1. Subtract 1 lot of n, which is just 1. And then plus 1 gives us this. Well, 1 minus 1 is 0, plus 1, that gives me 1, which is indeed the first term. What about when n is 2? Well, when n is 2, we get n squared. That's 2 squared, that's 4. Subtract n, that's subtract 2, and then plus 1. Well, 4 take away 2 is 2, plus 1 is 3. And that does indeed give us the second term. So I'm pretty confident that this is right. Okay, so the expression in terms of n for the nth term is n squared minus n plus 1. Now there were loads of steps there. Right, I really suggest you get to your revision guide, or your workbook rather, find the page on these and have a practice on them. Because the worst ones, where we've got to find out the number of n squareds, and then treat the next bit as an arithmetic sequence to work out the number of n's and then the constant at the end, Okay, it's quite a lot of steps, so make sure you practice doing those. N squared minus n plus 1. Okay, is 9,704 a term in this sequence? Well, if this was an arithmetic sequence, okay, we'd substitute in what we do. We'd set our nth term rule to equal 9,704, and then we'd find out whether we got some integer when we calculated that. Right here, we can treat this a lot more simply. Is 9,704 a term in the sequence? Well, let's look at the sequence. We've got 1, 3, 7, 13, 21. Can we notice that all of the terms in that sequence are odd? Now, is that always going to be true? Well, I think it must be, because what are we adding each time? We've got plus 2, plus 4, plus 6, plus 8. Okay, I assume we're going to get plus 10, plus 12. Right, we're always adding an even term to that last odd number. And if we add an even to an odd, okay, we're going to get an odd number every time. Every term in this sequence has to be odd. So is 9704 a term in the sequence? No, because all the terms are odd. And clearly 9704 is not odd, it's even. So we're done. Okay, so just a bit of thinking and looking. Could that possibly fit in the sequence? No. Okay, so right, if you're doing higher tier, definitely practice the quadratic sequences ones. The ones like question 1a, they're tricky. You need to learn the steps. Good luck. Okay, question 2 on the higher tier. On Monday, Toga, nice name. Toga catches 80 termites. Sounds like fun. He puts a mark on each termite, very small marks, I imagine. He then puts all 80 termites back in the nest. On Tuesday, Toga catches 60 termites. 12 of these have a mark on them. Work out an estimate for the total number of termites in the nest. Right, now, this is called a capture-recapture question, and there is a formula that you can learn to work these out. But we don't need to bother with the formula, we can just think it through. Okay, right, what we're saying is he catches 80. He catches 80 out of how many? Well, that's what we've got to work out or estimate. We don't know the total number. Okay, so let's say the total, let's just say that's T for total. So he catches 80 termites and he puts a mark on each of them and then puts all 80 termites back in the nest. So we're saying that 80 out of this total number is the fraction that he's marked. Okay, he's marked 80 of them out of this total. So 80 over T is the fraction. Okay, now he then catches 60 termites and 12 of those termites have a mark on them. Well, the fraction of termites that are marked has to stay the same. If we've got a random sample and if we've chosen our sample so it's not biased in any way, okay, then we'd expect the fraction of termites that are marked, okay, to be the same. The fraction should be the same in any size sample. So in this we can say that, well, 80 of the total, 80 out of T, 80 over T was the fraction that were marked. That's got to be equal to the fraction that are marked in this new sample. Okay, and what's that fraction? Well, it's 12 have marks on them out of the 60 that he took this time. So this is the way to start. Okay, we're going to pick out the two pairs of bits of data, if you like, put them together as a fraction, and we've got 80 over T equals 12 over 60. Now we could rearrange by multiplying by T, but as soon as I've got a fraction equal to a fraction like this, and my unknown, my T, my variable that I don't know is on the bottom, okay, I can flip both fractions, and it's going to save me a bit of rearranging. So I can say, well, that must mean that T over 80 is 60 over 12. And that's okay, we can flip both sides, okay, as long as we've got just a fraction on each side and our unknown is on the denominator of one of them, that's okay. Okay, if you would prefer, we could multiply both sides by T and we'll work the same way, but I'm going to flip both fractions. So now we've got to solve for T. So what could I do on the left hand side? Well, I could multiply by 80. If I multiply the left hand side by 80, it's just going to leave me with T, because T divided by 80 and then multiply by 80 just gives me T. So on the right hand side I've got 60 over 12 multiplied by 80. So we're nearly there. Okay, what is 60 divided by 12? Well, 60 divided by 12 is 5, and I've got 5 times 80. So T, the total number of termites, is 5 times 80, and I make that 400. Okay, we could do 8 times 5 is 40 and add another 0, or do what I do. If I have to multiply by 5, I times by 10, that gives me 800, then halve my answer. So T, the total, is